the domain. We have to take the denominator out and equal to 0. Now the result will be x is equal to all real numbers except -1 and 1. Now the x-intercept, we have to equal the function to 0, and then we have 0 equals to the function. And the result gives x equal to +2 and -2. And we have 2 points, point A that is 2, 0, and point B that is -2, 0. Now the y-intercept, that is, we have to equal all the x to 0, and then we have the, so we have that the y-intercept is equal to the point, 0, 4.
To have an even symmetry, the f of minus x is going to be equal to the original function x squared minus 4 over plus x squared minus 1, that is the same as the original function. The vertical asymptotes and the gaps. First of all, we have to factorize it, and like we know, the original function, we have a difference of squares that is going to be x. We cannot simplify any factors, so that's why we don't have any gaps like we explained here. But we have two vertical asymptotes. That is going to be
by x, the limit of x reaching the infinite. So what we have to do first is divide every factor by the x with the biggest exponent. So which gives us that y, so the horizontal asymptote is equal to 1. How we need the first derivative? We have the quotient rule, which and 8x minus 2x is 6x, so we have it here, and then this one remains the same, so this is the first derivative. And in order to have the concavity test, we have to equal the function to 0, so we have that x equals 0. So now we have that in this division, negative and positive gives us negative. So in this case, where we use f of -2, the graph is going to be decreasing. And in this case, we use f of 2 positive. The division gives us positive over positive, which is equals to positive. So in this case, the graph is going to be increasing.
to use the limit of the function when x is -1, where it's at the left side. So that is going to give us -3 over 0 when 0 minus, that is when it's from the left, and this minus times over minus is going to give us plus, but then we multiply this times -1, because if we don't multiply it, our graph is going to give us on the other side, and when we multiply this -1, it gives us on the right side, because here in the denominator we have a square. If we don't have a square, we do not have to multiply this -1. Then we are going to do the same, but positive. Then minus over plus is going to be minus, but then we multiply again times -1, that is going to give us plus infinite. And here we have two different limits. Here we have the two different limits when it's on the left and when it's on the right. So then the general, the limit of when it's -1 in general does not exist. Derivative, we use a quotient rule first of all, that is going to be this. But when this the other part that is going to be the derivative of the numerator is a chain rule that is going to be applied like this. So then a common factor is going to be -6, and this is our final answer.
So now we're going to do the concavity test of the second derivative, which we equal the function to 0, and after
which makes us cannot perform the concavity test because it's an imaginary root. So therefore, the identity test cannot be determined.